And we've been talking about the endocrine system. Up to this point, we have talked about how we have our connection, with the hypothalamus, and there's this stalk hanging called the infundibulum that is got hanging from it is the pituitary gland. Now, the pituitary gland, a couple of things to remember. Anterior pituitary, posterior pituitary. Anterior is cellular. Posterior is nervous tissue. So definitely want you guys to remember that. Up to this point, we have talked about the hormones that are going to be released, secreted from the hypothalamus, and they're going to have to make their way to the pituitary gland. The hormones of the hypothalamus, they are either secreting or inhibiting. Do you guys remember that? Okay, like the thyrotropin secreting hormone. And where did that go? The thyrotropin secreting hormone. And do you happen to remember where it went? It went from the hypothalamus to the anterior pituitary. So if we think about that structure of the hypothalamus, all right, and the connection to my pituitary gland, if I have that thyrotropin releasing hormone get secreted, that means that it's going to travel by way. Do you guys remember how the information travels from the hypothalamus to the anterior pituitary? The portal system, okay? The blood, all right? That special capillary network going from the primary to the secondary. And then there would be cells located in my anterior pituitary. If this was thyrotropin releasing hormone, do you happen to know what hormone in the body that's going to deal with?
Thyrotropin?
What gland? My thyroid
gland.
My thyroid gland. So my thyrotropin releasing hormone will make its way to cells in the anterior pituitary that can make their product, which would be that thyroid stimulating hormone. Now, other cells are going to exist in my anterior pituitary, but not all of them are made for TRH to act on them. How is it that TRH will act on the cells that it's supposed to? What do the cells have?
The pumps.
Plasma membrane.
And the plasma membrane contains what?
Proteins.
Receptors. So my TRH can affect the cells that they're made for, which are going to be the cells to create my thyroid stimulating hormone. The TSH can make its way to the bloodstream. And from the bloodstream, which organ is it going to go to? If it's my thyroid stimulating hormone, it's going to go to my thyroid gland. So it's going to go to that gland of my thyroid because the TSH will circulate in the blood, and this gland, the cells that make it up, they're going to have what on them to accept the TSH? I'm going to have receptors. So the TSH will make its way to my thyroid gland, and because it is stimulating, what is it telling my thyroid to do? Make its hormone. Does that make sense? So if I have my hypothalamus that can only secrete hormones that are for releasing or inhibiting, that's going to tell the pituitary gland to either make the hormone or not. And so the pituitary gland will either make the product or not make it. The anterior pituitary, the posterior pituitary, both are controlled by the hypothalamus. One is the cellular component, one is the nervous tissue. Some of those hormones that we kind of mentioned, but are also listed in that table in your textbook, we've got our hormones such as the prolactin, but from the hypothalamus, that one's inhibiting because the only time it needs to be releasing is at the time of childbirth and after for mammary glands to work. Everything else is pretty much going to be a releasing hormone. So from that anterior pituitary, we're going to get thyroid stimulating hormone, luteinizing hormone, adrenocorticotropic hormone. We're going to get growth hormone. They're going to have their target tissues and organs that they're going to act upon in the body. When we look at the posterior pituitary, did we go over this already? Just this one? Yeah. Well, it's not going to hurt us to go over again. Okay, so remember the connection between the hypothalamus and the posterior pituitary, nervous tissue. Do you remember what, for that infundibulum, what is that referred to for the connection between the hypothalamus and the posterior pituitary? Do you remember the name of it?
A tract?
It's a tract, that hypothalamo-hypophyseal tract. I know it's got this long name. This is the side, this is the part of the pituitary gland that can store the hormones. The anterior pituitary cannot. So the posterior pituitary stores the hormones made in the the hypothalamus. Okay, so note what I just told you. These are hormones that are made, synthesized in that posterior pituitary. So that little nerve cell body creates its product. It travels down the axons that go to the posterior pituitary, and they just basically release their chemical. And there's only the two. Our anti-diuretic hormone and oxytocin. So these would be readily available. Hormones from the anterior pituitary are not. They have to be made when they get the message. So there is a difference between the production of the hormones from anterior to posterior. The job of antidiuretic help the body retain water. In the times of dehydration, help the body retain the water. Oxytocin is going to serve a couple of different functions. The majority is for reproduction. So at childbirth, it's going to stimulate labor contractions, and it's going to help with the flow of milk to the mammary glands. Brian?
I'm having a hard time understanding how vasoconstriction would help retain water.
Now, vasoconstriction. Let's think about what happens when vessels dilate. Now, at the area of the body where vessels dilate, okay, and there can be exchange. That's at my capillary beds. That means that would be, if I'm trying to retain water, that means those capillary beds would not open for me to sweat. Okay? One of the things that happens when you get overheated and you don't have enough fluid in your body, for example, because you know when the body overheats, the way that we kind of get rid of that heat in the core is that hot blood circulates to the capillary beds. The capillary beds kind of dilate and the heat evaporates out, and that's our sweat. Well, if I need to retain all the water I can't have that happen. So that means all of that warmed up blood cannot leave, or it cannot disperse its heat. If you're, say for example, because even though the temperature outside today isn't very high, it's only supposed to be like what, about 80? But what's the humidity out there right now? Okay, you go out there right now and you might think, well, it's only 80 degrees, but oh my goodness, 96% humidity. But I'm going to go out here and I'm going to cut the grass and I'm going to weed eat and I'm going to rake the leaves and all this sort of stuff, and you're going to sweat if you don't replace those fluids, all right? ADH is going to kick in. And if it has to kick in to the point you are no longer sweating, you're in trouble.
So when that happens, because when I exercise and stuff, like my fingers swell, but for the reason that you were just saying. But I guess, you know, like if that stops happening, I guess you're in like a dangerous